Okay, good day and welcome back to this lecture. This is the fifth lecture in our series on the course of Geoenvironmental Engineering, and our second lecture in the module on design of waste disposal facilities or design of landfills. So in the last lecture we looked at generation of solid waste and how we are placing it on the ground. And one of the messages which you might have carried from last time was that we produce thousands of tons, thousands of million tons of waste per year in a country. So when we are talking about the quantity of waste, typically, for example, if you just look at ash, we are dealing with maybe 120 million tons per year. And if you are looking at mining waste, we are talking of more than 1,000 million tons per year. So how do we solve this problem? Waste, as we put it on land, accumulates with time. So I start with a small waste dump, and over the years two things happen. We spread it over more and more land till we find that the more land is not available. Then it becomes higher and higher because we don't have more land, so the waste dumps come higher and higher. And you will often see waste dumps which look like huge mounds. How do we tackle this problem? And one question which I put up in the last class was, can we become a zero waste society? So somebody said yes. So the title of today's lecture is Waste Minimization by Integrated Solid Waste Management. So to look at this problem, and this is a huge subject, integrated solid waste management can itself have 42 lectures on it, and we don't want to get drawn into trying to become waste managers. Our job is to design waste disposal facilities which don't impact the environment around the place where these are disposed. But nevertheless, some of you said that we can become, anybody who wants to say we can become a zero waste society or a very low waste society? Okay, tell me two steps which you think would help us become a zero waste society. So source segregation, I don't know how it will make the waste disappear, but source segregation is an attempt to minimize waste. But still, you segregate the waste, it is still waste.
And then segregation by authorities and then waste energy plants.
So if I segregate waste into, say, two components, the biodegradables and non-biodegradables, still I have two wastes. Then what you're saying is I can send waste for processing to a composting plant and to a waste to energy plant. So by waste segregation and waste processing, I can minimize waste. But can I become a zero waste society? Because even when you burn everything, there is ash. Suppose I burn everything, I still have some ash. And is the ash inert, non-hazardous or hazardous? Well, some ash is observed to be hazardous, some ash is observed to be non-hazardous. But in the end, I still have this ash, and this has to be put somewhere on the ground. So it's going to consume land. The only way we can say that we'll become a zero waste society is if we don't have any end product to put in a dump. So we have not reached that situation, but we are definitely trying to reduce the quantity of waste. So what we are trying to say is, if I have a bathtub which is full, which is like the landfill capacity is full, and if the water is overflowing from the bathtub, I am looking for a solution for this problem. Now the solution is not to do a lot of engineering here. Water is coming out of the bathtub all the time, you'll say, all right, get me a bucket, get me another bucket, get me another bucket. But that's not a solution to the problem. The solution to the problem is close the tap. So waste minimization means, please remember what is the important thing. The important thing is to close the tap. The important thing is to get as little waste out from your sources as possible. And if you do that, waste gets minimized. So in the context of today's lecture, suppose today we are producing 100 units of waste. Can we do various kinds of things and reduce it to half its value or 25% of its value or even lower? So that is waste management, integrated solid waste management and waste minimization. Our job will always be that whatever waste is coming out, we still have to dispose it on land, and we should dispose it in a manner we don't affect the human beings and the ecosystem around it. So the objectives are to minimize waste and effectively manage the waste still produced. So integrated solid waste management recognizes that we will not in the immediate future become a zero waste society, but let's reduce the waste. Okay? So what are the steps that we can take to reduce the waste? Are these 1, 2, 3, 4, 5 steps? So first step is waste reduction at source. Please produce less waste as a householder, as a human being, and that's a big step forward. How can we reduce waste? We can reduce waste by using materials more efficiently and making differences in the packaging, and we'll come to that later, because much of the waste is the packaging of the products. After waste reduction, we can try resource recovery through separation and recycling. So what was said was, it was said that we should do segregation, we should do segregation, and we should recycle what can be used. So in current tech context, glass can be reused, metals can be reused. So all the stuff which the kabadiwala from the house takes away is the recyclable stuff. The paper is being taken away. So we can do resource recovery through separation and recycling. If we mix everything, if we mix the paper with the food waste, we've lost it. So keep it separate and send it for recycling. It has its implications on the number of streams for collection that you have to set up. It's not that simple that you keep it separated. It's, do you have separate streams to collect it and send it to the separate units which are going to use it? If you are not able to recycle something after separation, can we do some waste processing and help further resource recovery? And what are the resources we are talking of? The two resources which we are using from the environment at the moment. No, we are using energy and raw materials. And we want to recover energy and raw materials, and materials which can become raw materials for the processes, because then we will need less raw materials and less energy. So can we recover energy through waste processing? Can we transform the waste so that it occupies lower land than it would have otherwise? And finally, we do waste disposal on land. So these are the options that we have to look at. So we did this diagram earlier. We are taking from the environment energy and raw material, and we are disposing the solid waste. If we are producing gaseous waste and if we are producing liquid waste, which we are, what is happening? The gaseous waste is being treated and it produces solid waste. The liquid waste is being treated and it produces solid waste. So all that is eventually permanently lying on the ground is the solid waste. Just to recall, electrostatic precipitators will reduce the smoke coming out or the particles coming out with the gases, but it will give you ash. ETP sludge is the output of treating wastewater so that the wastewater is not contaminated, but the sludge will have the contaminants, and all of them will come on land. When I do integrated solid waste management, I look at the waste which is coming out from any process and I apply the principles. Can we reduce waste? Can we recycle it? Can we process it? Or can we transform it? So if I am able to take out some materials, suppose I am able to take out the glasses and the metals, then what happens? The glass industry now gets an input from the recyclables. So it uses less raw material. Suppose the waste which is coming out is paper, and if I can burn the paper to recover energy, then the energy input to the industry from outside sources is reduced. So integrated solid waste management means you look at all the alternatives and see how I can reduce the energy being taken from the environment and reduce the raw materials. Then I have the products, then I have the consumptive processes. Now here is where the municipal solid waste comes out. And here also we can apply the same principles. If I have municipal solid waste, what can I store separately? What can I recycle for the materials? And what can I recycle for energy recovery such that less energy and less materials? So we get less solid waste to dispose on land. The size of the landfill becomes less, and we have less energy to be taken from the environment. So in terms of hierarchy, the maximum money should be spent if we are subsidizing or if we are catalyzing something. We are trying to invest as a government. Maximum money should be spent on waste minimization and reduction at source. If waste is not created, then our problems are lesser. If more investments have to be made, they should be made in terms of material recycling and waste processing. Material recycling is higher in the hierarchy because here you are able to get the materials without putting energy into the process. In waste processing, you might have to put in a little energy so that you can recover the other things. Finally, waste transformation and landfilling. So everybody agrees with this? Anybody has any alternate thoughts that no, we could do it differently? So the question is, how many processing units, where are they going to be located, what is the optimal solution? Is it one big integrated facility, or is it that small units are lying everywhere? Let me articulate that. And we are not going to look at those solutions yet, but if I geographically or in plan, if I look at a city, and the question being asked is there going to be one big facility with smaller facilities here? Recycling, waste processing, landfilling? Or are there going to be different units spread around? Both solutions are being used in different situations. There's no one solution which is the ideal solution. So you may have a centralized TSDF, as I said, treatment, storage and disposal facility, or you may have individual units all around it. So that will depend on how the plan area of a city and how large it is, how large are the distances. If this distance is 5 kilometers, that is one solution. But if this distance is 50 kilometers, then you have another solution. So those solutions will be given to you by integrated solid waste management, where you can see how much are the transportation costs and how much are the processing costs. Normally speaking, today what is evident is that when you deal with waste, we are dealing with odorous compounds. It's better to put everything in one place, because you can more intensively control things at the boundaries. If you spread them at too many places, then each place requires environmental control, stringent environmental control. But this is not the only consideration. Transportation costs and other things are major considerations which we have to take into account. How do we reduce waste at source? So I talked about proper manufacturing and packaging of products for longer useful life. So let me say, again we come back to the example of shampoo. You are using shampoo, so you buy a small bottle. And every 15 days you go and buy another small bottle. And then at the end of the year, you have got as your waste, how many weeks in a year? 52, and we are doing alternate week, we are buying a new small shampoo bottle. So we've got 26 small shampoo bottles. My friend here, he says, I will buy my shampoo for 1 year in one go. So he buys a large bottle. And the manufacturer, who says, I do environmentally conscious manufacturing, says, I'll give you a more concentrated solution. So instead of putting 4 drops of shampoo, you can use 1 drop of shampoo. Right? So he has a product which is manufactured and packaged for longer life and less waste. He may not have the money to buy it because he's getting his salary every month, and for him to buy everything for a year, he may say, no, I don't have the money. But the point is, you can, with proper manufacturing and with sensible efficiencies, reduce the packaging. The other thing is, you may go from toxic to non-toxic materials, or you may go from artificial to natural materials. Some of the herbal compounds, some of the organic farming compounds. So these may be producing less waste coming out of the system than your very strong surfactants and detergents and other products which may be having a higher effect on the environment. So you may phase out the artificial materials by more natural materials. And you may do selective reuse of these materials as well. Again, let's take an example. You have a person who's making a packaging material. Now, if the packaging material is recyclable, is it better or is it worse? It's better. So, glass bottles are better than tin cans. You remember a time when all the beverages used to come in glass bottles? And what used to happen? All the glass bottles used to be collected back. Why? Because you could just wash them and refill them. Now what is it? We've got plastic bottles and tin cans. And do we give it back to the shopkeeper? We toss it as if into the dustbin, as if by some magic they will disappear. So selective reuse means use a packaging material which can be reused. And many countries are now making this last legislation. The packaging material will have to be taken back by the manufacturer. Otherwise, he has to pay a tax. Why should the municipality take care of the packaging material? So maybe we'll go back to glass bottles. Or maybe if you have plastic bottles, please take back your plastic bottles and recycle them. Wash them, clean them, and recycle them. So that's how you reduce waste at source. In some of the developed societies, a huge debate is on the responsibility of the manufacturers. Then, as I said, resource recovery through recycling. It's easier said than done. Recycling is not that simple. You have to keep each item separately, virtually. The more segregated you are, the more you can reuse it. Now, in a country like India, where the kabadiwala comes to your house, he can take each individual item. He'll take the glass bottle separately, he'll take the tin can separately, he'll take the newspaper separately, he will take each individual. But in a more industrialized society where everything is mechanized, the tendency is you can keep them separate, but somebody is going to come and collect them, a machine or a truck will come and collect them. Now, if you have 10 bins, it's not only about keeping them separately, you should be able to collect them and take them to different places for doing different things with them. So the weakest link in the chain is, one, the householder may not keep them separately. He's too lethargic or lazy to keep things separately. The second is, even if he does, you may not be able to set up 10 streams for collecting different components of the waste because it's too expensive. So, nevertheless, this is the area which requires the strongest funding other than waste reduction at source. You do separate storage. So now some countries have 5-bin system. We are trying to go from 1 bin to the 2 bin, dry waste and wet waste. But there are some countries which have 5. I mean, there is a hazardous waste which comes out from the paints, nail polish removers, lead acid batteries, they come out from the household, the medicines. So you have to have a hazardous waste bin. Then you have to have a recyclables bin, the paper, the other stuff. Then you have a food waste bin. Then you have a metals and metals bin. Then you have an electronics bin. So you have 5 bins. adoption is not very high still in these various countries, but they are trying to go towards that system. Then once you are taking these, you have to process these and remanufacture. It's not just you will take metal and it will get recycled. You have to go through a process of removing the paint, making a new a can out of it, or if you have a plastic bag, you can melt it and reuse it. But the recycled bags, how do you know you are using a recycled bag? What is the color of a recycled plastic bag? Very ambitious. Which is the color which is the easiest to manufacture? White is the most difficult. Black. So all the black thalis that you get for putting your garbage in it, progressively the color which is mixed with the plastic keeps on making the bag darker and darker, and eventually the recycled plastic looks black. So remember that in all probability the transparent or the white plastic is the original plastic and the recycled plastic is black. So you can recycle it, but how much can you keep the color away from the plastic? And all these materials can be recycled. And of course, if I want to do further recovery, I mean, I have food waste, I can't recycle food, but you can send it. I mean, the hostel food, where does it go? The food waste from the hostels? All the food which is left over. If the food is left, there are two kinds of waste. One is the excess food. So if the excess food can always be sent to a underprivileged, you can work out a mechanism that it can reach the underprivileged people. But if the waste which has gone into the dustbin, where does it go? It can go to a piggery. Pigs can eat it or animals can eat it. But then again you need a separate collection and transportation and delivery system. You may be here and the pigs may be 25 kilometers away. Right? So anyways, after recycling and reuse, you can do processing. So you can convert your municipal solid waste into compost by aerobic processes and anaerobic digestion. You can do biomethanization. A methane can give you energy. You can do thermal treatment. You can burn it. You can, from the municipal solid waste, you can take out the paper and the plastic and the rags for refuse-derived fuel, which can be used for energy recovery. If you have ash, if you have construction and demolition waste, can you use it for building blocks? Can you use the ash in roads and embankments if it's not hazardous? Instead of using earth, which you will dig up from some farmer's place, can you do that? And you can also do some chemical treatment for recovery of compounds. So all these resource recovery processes require more investments in terms of giving energy and materials to make this happen. But in the end, the recoverables do outweigh the investments which are made. After this, we may still have some waste left and we might want to transform the waste. For example, you might want to shred the waste to make it into smaller. You have large sized waste, you can shred it or you can grind it. You can do size separation through screening. Mixed waste is coming to you to a site. You do screening. The waste which is more than, what is the size? How many mm is this? Or how many centimeters is this? Yeah, so let's say this is 4 inches. 4 inches is how many mm? So anything above 100 mm, maybe it will be only C&D waste which was mixed wrongly. So you can do screening, and from the screening you can transform the waste by getting separate fragments. You can do volume reduction. Your waste is very loose. You can send it through compactors to bale them and to make them into denser arrangement. You can stabilize the waste. The waste is hazardous. You can mix it with cement and lime such that the toxicity goes down, because the cement will react with the matrix, and when you do a leaching test, that much hazardous material will not come out. And you can also do encapsulation. That means you have very toxic waste. You can embed it in the middle of a brick or into a glassy matrix so that it does not come out. So waste transformation is the next step after waste processing. And then finally, of course, you will do the disposal on land. So for the solid waste that cannot be recycled or processed, you see every waste when it goes to a plant, don't think it vanishes. Suppose waste goes to an incineration plant and they'll burn it. Firstly, the incineration plant fellow will say, I can't take all the waste, I will do pre-processing. So he will do pre-processing, he will remove the construction and demolition debris which is mixed with all kinds of stuff. He will take the finer fraction, he'll burn it, ash will come out. So some of the waste will get processed and reused, but there will be rejects. So from each plant you get rejects. The rejects have to come for disposal to the land. So waste does not vanish if you send it for processing. Some rejects still come back to you all the time. So for the solid waste that cannot be recycled or processed, you will dispose on land, and for the residual waste after all types of processing have been undertaken, that means all the rejects coming out of the various plants. And this is an interesting table. We'll come back to this first. So there are two components of the waste which is disposed of on land, that waste which cannot be used for anything. Suppose the waste is very intricately mixed and you can see the components on it, but you have a tea bag mixed with your food waste, mixed with something else. I mean, unless you actually go into it, cut the tea bag and remove the stuff, you have waste which is in a plastic bag and the plastic bag is closed from the top and dumped into your. Unless you shred the plastic bag, you can't go inside to remove what's inside it. It's complex. The more you mix the waste, the more useless it becomes, and it's not possible to get the constituents back again from it. So there will be waste which cannot be recycled or processed. All industry will say, this is not good enough for me. And those which can be recycled and processed, they will give you residual waste. That will also come to the land. So if I look at the type of waste which is coming out in different countries, this is the components, this is municipal solid waste, paper, plastic, metals, glass, rubber, leather and textiles, wood, biodegradable, inerts, other. So first remember, inerts is not like true inerts, it's like construction and demolition waste. So if I see India here, and if I see US, UK, Europe, you find a lot of paper and cardboard here, but not here. And the answer to that is the kabadiwala system, the household collection, individual collection system. Our paper goes to them. Plastics are similar. Nobody wants these fine plastics, especially these thin bags. They have very little recyclable value. Anything which has a recyclable value will be taken away. So metals also you find in India, they go down. Glass also in India, your beer bottles or your any other bottles, they go down. So rubber, leather and textiles I think is underreported in India. We think this is higher. This would also be about 5 to 6 or 9% in India, especially the rags which are there. Wood is also higher. In fact, these figures are probably a little underreported, but nevertheless we'll take them at this value. But suddenly you find, because there are so many other things in the waste of other countries, the biodegradable component is a little low, right? Whereas in India, the other components have been reduced by the kabadiwala. Therefore, the biodegradable components are high. So Indian waste is a wet waste. It's got a lot of food waste in comparison to other countries. And if you have a lot of paper and cardboard and plastics, you can burn that. It will give you energy if you do proper control for dioxins and everything. But if you have low quantity, then it may not give you energy unless you segregate. So, and the other thing which you see very high in India is the construction and demolition waste. In the developed world, there is a separate stream for collecting this, and this is a well set out industry. You will recycle your C&D waste. You have C&D waste processing plants. Whereas in India, we are just starting. So at the moment, almost all the waste which comes is about 25% construction and demolition waste. Any observations on this table? Anything you'd like to discuss? Any clarifications? Okay. If you have a high biodegradable fraction, the optimum route is to do a biological treatment. And the optimum route is basically composting here. If you have high combustible fraction, the optimum route is to go for energy recovery by thermal treatment. That means incineration. You burn the combustible material. If you have high inert content, do physical treatment. Make building blocks, make embankments. So these are the broad guidelines which we have. And the important thing is, if the waste has been stored separately into the separate fractions, and if we have the streams to collect that, we can use it for the purpose. However, if all these components become mixed with each other, then it has no value. And an important example is that about 25-30 years ago, the first waste to energy plant was set up in Delhi by international funding. But nobody realized that the technology that they were using was coming from Europe and the US. But nobody realized that we have no energy content. And you know, this error can be made if your sample size is not large. Typically, if you want to find the energy content of municipal solid waste, what should be your sample size? In soil mechanics, what is your sample size? If you want to do liquid limit, plastic limit, how many grams? Well, at least I'll take 100 grams, be on the safe side. 100 grams will come in my hand. Now I'm trying to make you visualize. You want to characterize municipal solid waste. What should be the size of your sample in terms of volume or in terms of weight? 100 grams, you want to take 1 kilogram? Is that a good size to? Anybody? 100 grams was for soil, 200 grams for a triaxial test, 2 kilograms for a Proctor test. That's the kind of sample size that we are talking about. How much for a municipal solid waste? Well, I would like to take a municipal solid waste which is at least 1 cubic meters, 1 meter by 1 meter by 1 meter. Why? Because it's very heterogeneous. It might have a huge boulder, it might have a broken piece of your window, a broken piece of your chair, so it might have large size material. So if you take 100 grams and go and do the energy content, your reading is not likely to be correct. So one of the reasons at that time I think there was an error was that the sampling was not large enough to represent the energy content of total waste. So a plant was set up and it never was able to recover energy from it. So it's important to understand that if you store things separately and if your energy content is good, you can get energy out of it. Mixed waste really has no value. Can we unmix it? The question always is, can we unmix waste? Yes, I can grossly unmix waste. I can do screening, I can do magnetic separation, I can do air separation, but I cannot intimately unmix it. I cannot remove the tea from the tea bag and say my paper is here and my tea is here or the thread is here. So unmixing is difficult. Separation or sorting of mixed waste is tedious. It's expensive and often non-executable. So separation at the source is most desirable, but that depends on the person who's producing the waste, and secondly, it depends on who is going to collect the separate streams. The municipalities therefore must have the separate systems for collecting and working on that. That means if I want your construction and demolition waste separately, I must be able to get it from you, and my stream must go to a C&D plant. The other issue is that if there are some hazardous components, if you mix your hazardous components into your non-hazardous waste, you render it hazardous. So presence of hazardous components render the end products of processing to be of limited use. Let me say, I'll do composting to my biodegradable fraction of municipal solid waste. Now, the compost must meet my standards set up for applying of fertilizers and compost to crops, to grow crops which are going to be consumed by you and me. So the compost must have heavy metals within a limit and certain other things within some limits. Now, if you by mistake mix up the waste and make a compost of mixed waste, it may not meet the standards. So it may meet the standards in the industrialized world. There are separate standards for compost which can be used for flowers and gardens, which are not going to enter the human chain, vis-a-vis the compost which can be used for crops which are going to be consumed by human beings. So maybe the compost might meet a lower standard, but the very stringent standards, you then should be very clear that there should be no hazardous component to it. And the more processing devices that you set up, the more is the odor issue that you are handling. All waste has a smell. You go to any area, you go to an industrial area and you'll start getting a particular smell in the air. And that is the smell because of the gases coming out of the chimneys. And you go to the waste dump and that smell will be all pervasive. Now you say, I'll send this for waste to energy, I'll send this for composting. Wherever you send it, you create more odor. Wherever you send it, you create more odor. And then you have to do the odor control. So pollution control measures are necessary at all treatment plants. And you keep on hearing about some residents being up in arms against the waste to energy plant in Okhla or the composting plant in the newspapers every now and then. Why? Because they are bothered by the odor. So ideally these should be far away. Typically odor will travel 3 to 5 kilometers from a facility. Either you should have very stringent odor control mechanisms which are expensive, or you should be far away. So this have to be taken into account. So all that we are saying is that this integrated solid waste management is very important. It can be done at the household level, which is the best, but then you are dealing with tens of thousands of people and making them fall in line. It can be done at the community level. You may say, all right, I will not do so much at the household level. I would like to do composting at the community level or waste to energy of my society. I'll do biomethanization and take the methane out. Or it can be done at a central level in a city, or it can be done at a central level in the city. So for the big cities, there's a lot of demand for centralized facilities, which should be a little away from the city, and we should do everything in a mechanized manner. But in the smaller cities, one can look at household and community level initiatives. So the ultimate integrated solid waste management system comes in looking at the alternatives at all the three levels and then arriving at the solutions for your integrated solid waste. If you invest in all this, then the amount of waste reaching the land is lesser. So less land area is used and the height of the dumps becomes smaller. So we will carry on this discussion about this integrated waste management by looking at some recent initiatives which we have started. We'll look at some examples where this is working, beginning to make an impact, and the waste reaching the sites is reduced. But for today, we'll stop at this juncture, and I'll be happy to take any questions that you may have at this stage. So we started with the thought that can we have a zero waste society? So after this discussion, how many of you think we can have a zero waste society? Raise your hands. We're a class of 15. Let me see how many hands think. One of us thinks that we can have a zero waste society. Wonderful. How many of us think that we can have a low waste society? Low waste. So 14 out of 15 think that we can have a low waste society. And what is low? If today we are producing 100 units of waste, our target should be that 100 should become 50 in the near term, and perhaps 25 in the long term. And by that time, maybe some treatment techniques would have come, low cost, low energy treatment techniques, where we can actually make all the waste disappear. And then we can have a zero waste society, as one or some of us are optimistic about it. But you keep on reading about these experiments that people live together for 365 days in a dome, and they wanted to see whether they can live without energy and without raw materials from outside. How many of you saw the movie The Martian? In that Martian also, he has to set up an ecosystem where he has to sustain himself without energy and without raw materials from outside. That's the dream, that we'll be a zero waste society and there will be no waste. Till that time, environmental geotechnology or geoenvironmental engineering will continue to remain an important subject, and we'll discuss that in the next class. Thank you.